Welcome guys, hope you are doing great. Today we are going to start the next video lecture that is about uncertainty. Okay, so we can define uncertainty as the magnitude of doubt or error in any measurement. Right, so it is the magnitude of error in a measurement. In every measurement, there is always a chance of some sort of error because no measurement can be made, in a perfect manner. Now, what does mean by this error? Error is actually the possible deviation from the actual value. So, this possible deviation can occur due to multiple reasons, like error can be there due to random change in physical conditions if someone is performing an experiment and suddenly the physical condition changes, right? So at that time the result can vary. It can also be there due to faulty apparatus, due to zero error, and sometimes it can occur due to personal negligence. Now, how we are going to represent any measurement? If we consider uncertainty at that time, in order to completely represent a measurement, we will write measurement can be represented as actual value plus some deviation or possible deviation, right? Okay, if we take an example, let's say if we measure the mass of any small object and we found that its mass is, including the uncertainty that depend upon the least count of our measuring instrument. Let's say the mass is found to be 3 and there is a possible uncertainty of 0.2, and let's say we are measuring with an instrument having the least count of gram, right? So that is the way in order to represent any measurement by considering the uncertainty or the possible uncertainty. There are two basic ways to represent uncertainties. The first one is absolute uncertainty. Okay, so this is such a way in which the uncertainty takes some unit. So it will be having unit. So in the above case, 3 plus minus 0.02 gram. Here this 0.2 is the possible uncertainty and this is absolute uncertainty because it has the same unit as our measured physical quantity. The second one is, it is represented with delta, in case of previous example, delta n, right? The second one is percent or relative uncertainty, percentage or percent uncertainty. Okay, it doesn't have any value, it doesn't have any unit, right? And here we are going to find out the total percentage uncertainty in any given measurement. Like if we are having 0.2 gram uncertainty in our measurement, then we are interested in finding that how much percentage this value will become of the total value, right? So for that, what we have to do, we have to multiply the absolute uncertainty with the total value and then we have to divide that by 100. So this gives us percentage uncertainty and we can write percentage uncertainty in this way. So percentage uncertainty can be found by multiplying absolute uncertainty with the total or actual value and dividing that value by 100, right? Okay. Next, we are going to discuss 3 different cases. Those cases are very important in the context of first year physics because we are, we will be dealing with different physical quantities, and those physical quantities sometimes they are in addition form, sometimes they are in product forms, and in some cases we are even having exponent, right? So how we are going to find uncertainties in such situations? So for that we have to look at 3 different cases. 3 different cases are: some are difference. When 2 physical quantities are in addition, what will be the total uncertainty in such kind of calculation? And if they are, if we are going to find difference between 2 physical quantities, again, we need to find the total uncertainty in the measurement, in the calculation, right? So for that, let us consider that we are having 2 physical quantities. The first physical quantity we call A, and the possible uncertainty can be represented with delta A. The second physical quantity is, let's say, B, and the possible uncertainty in B is delta B, right? So in case of sum, when we add 2 physical quantities, let's say that the addition of such 2 quantities gives us another physical quantity. We call that as Z, and Z plus minus, because again there will be a kind of uncertainty in the final result, and that uncertainty is delta Z, right? So this is equal to A plus minus delta A plus B plus minus delta B. So actually this is the sum of 2 physical quantities. Now let's say that A is equal to 6 and the uncertainty in A, delta A is equal to 0.3, and B is equal to 4 and the uncertainty in B is equal to 0.2. Now we are going to find the magnitude of Z and the uncertainty in Z, right? So this implies that Z plus minus delta Z, it can be written as, we have to just replace the values, plus instead of B we are having 4 and plus 0.2. Okay, now whenever 2 quantities are in some form, their uncertainties will be added. So simply what we have to do, we have to add the uncertainties in order to find the total uncertainty, right? So Z will be equal to 6 plus 4, 10, and the total uncertainty delta Z will be equal to delta A plus delta B. So that gives us 0.3 plus 0.2, 0.5. So this implies that Z plus minus delta Z, that is the possible uncertainty in Z, and we can write it 10 plus minus 0.5. So this is how we can find the uncertainty in such a calculation where addition is involved or subtraction is involved. So regardless of whether we are adding or we are finding the difference between 2 physical quantities, we have to add the uncertainties in such physical quantities, whether they are being added or subtracted, right? Okay, I hope that you can do the same for the difference. Is for such calculation where product is involved or quotient is involved. Okay, now in such cases, how we are going to find the possible uncertainty in the measurement? For that, let us again consider 2 physical quantities, A plus minus delta A, the first one, right? We have already measured their magnitude. The second one we call B plus minus delta B. Now we are considering such a case where these two physical quantities are in product, right? So Z is actually A into B. If we completely represent it, even including its uncertainty in the measurement, so delta Z would be equal to A plus delta A into B plus delta B. Okay, now what we have to do, whenever two quantities are in product, in order to find the total uncertainty in the measurement, you have to add the percentage uncertainty in individual physical quantities. So first we have to find the percentage uncertainty in A, and then the percentage uncertainty in B, and then you have to add those percentage uncertainties in order to find the uncertainty in our final result, right? So this implies that the percentage uncertainty in A, it would be equal to, we can take the same example like A is equal to 6, delta A is equal to 0.3, B is equal to 4, delta B is equal to 0.2. Okay, so it would be 0.3 multiplied by 6 divided by 100. Once we will perform the calculation, we are going to get 0.018. 0.018. Okay, and the percentage uncertainty in B, it would be 0.2 multiplied by 4 divided by 100. Again, if you will do the calculation, you will get 0.08. 0.0008, I think. 0.008. Okay, now, right, so Z plus minus delta Z. In order to find Z, you have to simply multiply A and B. So A multiplied by B, so 6 multiplied by 4 gives us 24. Okay, now the uncertainties in this case are the percentage uncertainty, and we have to add these percentage uncertainties, right? So 0.018, we have to add that with 0.008. Okay. Delta Z, that is the uncertainty in the total measured value, will be equal to 24 times. When you will add these two values, it will give us plus minus 24 and 0.34, I think 0.034. So that's how you can find uncertainty in case of two physical quantities that are in product, right? Okay. Now what is the use of discussing these different cases? Because we can apply such cases in real situation, like from Ohm's law we know that, let me use the other color. From Ohm's law we know that the voltage is equal to current times the resistance. Okay, if the value of current is given and that of resistance is given along with their uncertainties, right? Then you can find the voltage by just multiplying current and resistance. But you can also find the absolute or the uncertainty in voltage by just adding the percentage uncertainty in current and the percentage uncertainty in resistance. So there you can find many other such examples where two physical quantities are in product and they are actually related to another physical quantity like Newton's second law, F is equal to ma, right? Momentum, many other examples you can find. Okay, so let's move, and I hope that you can do the same for quotient, because you have to apply the same procedure Only you have to divide the two physical quantities. The rest of the things remain. So the next case is for power. So in case of power, the power will be multiplied by the percentage uncertainty. Like let's take an example that the physical quantity is related with another physical quantity, right? So z is equal to a to the power n, and let's say n is equal to 2. Now in such case, how we are going to find the uncertainty? So for that, first we will write that z plus minus delta z in terms of a plus minus delta a whole to the power n, right? So this is the right way to express any magnitude along with the possible uncertainty. Now next what we are going to do is we will find the percentage uncertainty in a, and that we have already found it is 0.018, and in order to find the percentage uncertainty in z, you have to multiply the power with the percentage uncertainty. So you know, for z you have to take the power of a, and that gives us 36, right? And when you will multiply 2 with it, you will get the possible or the percentage uncertainty in z. Okay. Now, as you have discussed all the three cases, let me give you a kind of assignment for brainstorming. Let us take that we are having two masses m1 and m2 separated by a distance r. Now, if the masses are given along with the possible uncertainties, and the distance between the masses is also given, and uncertainty is also given. Now, if someone asks you to find the force along with the possible uncertainty in the force, so you can find it by using all these three different methods, right? You can see the two masses are in product and they are in turn quotient with the radius, and you are having power over here, right? So I hope you can solve it. So that was all about today's lecture. If you want to watch more videos, don't forget to like, subscribe and share. See you in the next video.